Hello, Mr. Minnick, helping students learn Python and just in general computer science. Here we have a computer program in Python hosted at trinket.io, and when I click run, let's just see how it works first. Oh, nice user interface. Press spacebar or the lowercase letter r to roll the dice. So I click in this window just to make sure this window is active here, and I press the spacebar. And apparently I rolled a 1. And my player token moved 1 square. Just so you know, until somebody improves this, such as the person watching this video, you, right now the player's token is in the lower left corner of the square where it is landed on. Later you can figure out how to add 10 pixels and maybe in the X and Y directions to center it, but that's up to you to figure out. Okay, moving on, I press the spacebar again. I rolled a 2. It did move 2 squares. You can add it up. Okay, I rolled a 1. After a 2-second pause there, it moved ahead 1. That white square is what I call a special square. It has embedded computer logic that moves you ahead 1. It doesn't really say that, so it lacks good user interface, but I knew to wait 2 seconds there. Anyway, I'm pressing the spacebar again. Oh, I hopped over that special square. That would have sent me back to if I landed on that second filled in white square, just saying. I'm currently right here, and right there, that square right there, upper right of my blue token, that is square number 1, 2, 3, 4, 5, 6, 7, 8, 9. Just so you know, that is considered player position 9. I'm hitting the space bar again. Oh, there's a dog leg. Now the player cuts the corner like jaywalks. Maybe you can figure out how to animate it here and then make like a soldier's left turn 90 degrees and then move up, but maybe you don't want to do that upgrade. So maybe you just cut the corner. Anyway, I rolled some number that's now been taken off the screen, and whatever it was mathematically added up to 12 or greater. I don't think this code requires you to roll exactly like you might in Parcheesi to bring your last player home or backgammon. But anyway, this is more user-friendly, but you could change the code to make it more strict. All variations that you could distribute online or to friends, different upgrade versions or that. Okay, so right now, notice that if I hit the spacebar, it doesn't move anymore because game status is now false. Actually, the variable game in play is currently equal to false. We'll see why how it's smart and it knows the game's over. And I'd have to click run here to run it again. But in the future, we could build a little button there that when you click, it resets you. See future videos or see me for extra workshops or tutoring if you want to learn that. We've got to stop somewhere here with this version. Okay, so that's the current version. Now let's explore the code and understand computer science and specifically Python. So anyway, this is a workshop that's the 7th in a series. So I'm going to be skimming over some things that, well, the students in the classroom right now have already learned, but they could raise their hand and ask questions, or perhaps just see me after hours for extra remediation and learning. So anything that's in green is as a comment, good style. It's one of the official Computer Science Teachers Association K-12 standards. Just aligning this with what you should know. To document your program in order to make them easy to follow, test, and debug. 2-AP-19 for 11 to 14-year-olds should know how to do that. And high school kids, 14 to 16, should go further and even be able to demonstrate the development of complex programs in maybe a YouTube video like this. So see me later to learn how to make a polished video like this that explains in wording how to do this such sort of thing. Anyway, back to my polished video. We have line numbers over here just so you see that. So the top of a program usually has a bunch of green hashtag comments. And Python is very, very powerful because it allows you to import other people's functions and objects. So you don't have to, as they say, reinvent the wheel. So importing Turtle allows us later on to do things like, we've learned this before, but I'm reviewing, turtle.screen and change the background color of screen, turtle.turtle and have something that we can move around. Pen equals turtle.turtle. It lets me draw these white lines on top of the black background, and etc. So turtle graphics are cool. Not really used in industry, but very good in like learning situations like this. Random, now that's the bomb. That's cool. As I point out here, I'm using the rand_in function, and I'm also in this version using the random.choice function in my code later on. That somebody else wrote that function, and I'm just taking advantage of it. Hey, knowing how to use the imports, that is a nationally, or actually I'd argue internationally famous skill that somebody should have coming out of an education program in computer science or just self-taught. How to use other people's procedures, also known as functions, is one of the standards here that you should definitely, I can't find it right now at this moment, but it's in there somewhere. Okay, going back to my walkthrough video. So import time lets me do a pause later on, and random, of course, generates random dice rolls. Constants. We've already explained that, but it's always good to put constants on the dashboard of your car where you can like easily change the heat settings and the cooling settings, so you don't have to tinker down in the motor of your car every time you want to change the temperature of something. Like then you'd have to stop the car, turn it off, open up the hood, get your hands greasy, and that would just be annoying. So it's always nice to up at the top where you can reach it with like your arm's length and change. Cool, foreground color. Let's make it yellow. Duh, yellow. Now don't make it some weird color like weird color. That might be in your Crayola box, weird color. But it's not defined in the online Python API library that you could look up. And we've done that in previous workshops. So I'm just changing it to something standard that I half guess exists, running the program, and voila, it's all yellow now. Wow, that's so cool. So if you didn't know to type a constant and set it equal to yellow, then in all these like 3 or 100 places, like right here, and right here, and right here, and possibly other places in 100,000 lines of code, you'd have to change white to yellow and not miss one occurrence. But by using foreground color ahead of time, planned out in all those places, we can easily have coworkers make changes that you don't have time to make by changing white to yellow or vice versa there. Use constants, please. In a way, the more the merrier. Just saying. Question from the floor. I'm hitting pause. So it was just brought to my attention that I was flipping to another tab where you did not see the standards, the Computer Science Teachers Association standards that I was referring to. So just ignore that spot of the video and just trust me that the concepts are linked to things that you overall should be learning according to a lot of Jedi masters of the universe, like Mark Zuckerberg, Jack Dorsey, Steve Jobs, RAP, and Bill Gates, and some great ladies in the industry as well, and other educators like, well, me. Anyway, hey, somebody noticed something, and what's your question about this set of constants?
They're all capital.
Yeah, it's not a law that says you have to capitalize constant names. I could have put a lowercase r there just for measure, and then done it consistently down here. But it's standard that when you drive a car, that you drive on the right side of the road in the United States. So as long as everybody stays standard and consistent, whether you're using Python, Java, C++, or another language, then you can like pick up another language real quickly and make changes without reading the first book that was ever written. So it's a standard that's just typically done. And when you have 2 words or more, usually we separate them with an underscore, because you're not allowed to put spaces in variable or constant names. And it would not look good, especially to somebody that doesn't speak English as their first language. They wouldn't necessarily know that that's like 2 words. They might even think it's 3 words, for, ground, and color. So I put the underscore there. Again, it's a style thing. So constants, the more the merrier. And this constant, this is a new type, player colors. I haven't taught this previously in my 6 workshops before this. I put a set of square brackets in there, and it's a 3 for the price of 1. Instead of just being one that string value in double quotes, I put 3 in there with commas in between. And because this is just the rule in Python, I put square brackets. Square brackets surround what's called a list variable, as opposed to just a, well, plain variable. A list is a bunch of things that are usually consistent with a cohesive theme, like in this case, colors. You would not put like the word dolphins in here of a football team. That would make no sense at all. Probably do weird things when you ran the program. At any rate, this is called a list variable. And you'll see how I use that later on this week in this new variation of this program. And other things that you just should be able to change, if you take this to like the French people, instead of press spacebar or R to roll the dice, you would change this to press A, spacebar, the continue A, I think. Something like that. I took French like 100 years ago in high school, and that's probably not near correct, but you could easily change the language interface in just one edit if you use constants. Thank goodness for edit undo there. I can put it back to the way it was. Okay, so constants. They also can affect the layout of the board in this case. So later you'll see, or review with me, that square 5, for example, is in the XY grid location, X equals -20 and Y equals 0. But you could just, I don't know, throw people for a loop, and you could move it up the screen by changing that 0 to a 40, run the program, and just like that, I moved square 5. Now I have an annoying pen up and pen down that's being used inappropriately in TurtleGrafx, that straight line, but the program will still work, and this player will land there rather than the original phantom spot down here, because I coded using constants. And I even added white space to separate each board square from each other, and I added hashtag green comments over here for good style. So my code is not obfuscated, which means just cluttered and unreadable. So good style and all that. And I also, oh, look, to do. So anybody that's bored with this version of the program that has little ideas of how they could copy and paste square 12 and just put in more left bottom pairs and make this board wider, longer, make it into a Monopoly board, whatever you want. So right now I moved square 5 back to where it belonged. And that's just a look at the constants. So at this point, nothing has happened up to line 59. None of this code here is something that actually does anything. It's just setting constants equal to certain numbers and words. Now the action starts at line 66. On line 66, this is code that actually does something in Python. But it's really just the boring stuff of setting up the screen. So it's like lining the field with lines before a sports team plays on the field with markers for like where you have to kick the ball and not be offsides or score a touchdown or something. So I have 4 turtles being used for different things. There's the circle, that's the player. And I'm using the random.choice library function that's only available because I typed import random. I'm using random.choice. And random.choice picks one of the colors out of the list variable player colors at random. Every time you run the program here, you get a random color for your player. Blue, but now I'm checking it out. Look, it's blue again. What a coincidence. It's red this time, and it has a chance of being green at some point. So if you were, as the person that works in the office that's in charge of changing the colors, if it's Easter, maybe you put purple in there. If it's July 4th and you're in the United States of America, maybe you put like red, white, and blue as your 3 colors. So you can have fun with this, but you would not want to put black here because then it would be black on black and people wouldn't see the player. See, the background is currently black. So, make sure that you have good user interface. Maybe you want to hire a graphic artist. Seriously, coders aren't always good at necessarily everything that's involved in good software development these days. But the point is, random.choice is a built-in library function that allows you to have Python pick a random entry out of the list variable player colors if you use it the right way with all these parentheses. And I've already taught player.color, so I'm just packing it all together so that when it executes, it's efficient and it does it all in one shot. I could do something like this. Color of the day equals random.choice player colors. I could have done this, and then instead of random.choice player colors, I could have used the variable name that I just invented a second ago, color of the day. So this still works. Arguably, I'm wasting memory because I created a variable that I didn't need. I could have packed it all together like, oh, why do we have a separate salad plate from our main course plate? Why not just put the salad on the main plate and save the dishwasher or the person doing the human dishwashing by hand time? It's a matter of readability and organization. If your code uses extra variables like this, maybe it's more explanatory to the other coworker who's following it. But maybe you don't have the patience for that, and maybe your coworkers are all just as bright as you. So maybe you just keep it this way, the way I had it originally, and you don't use up the extra variable name. Okay, making sure it still works. Testing your program incrementally with small changes is one of the standards on that page that I can't easily show right now. So always make small changes at a time and test it continually. It's a good way of developing code. Okay, moving on. This is all just standard stuff, but I do want to stress this week in this walkthrough video, this right here. The variable player position is going to keep track of where the player is. So I started obviously at 1, because that's square one in my mind. And the game is currently in play, true. In the old days, we used to consider true to be just the number 1, but now there's this Boolean data type called true, or it could be false. So this variable is going to control the game in a way that at some point you will see that if game in play is equal to false, it basically aborts and does a return and does not allow the player to move. So it freezes the player when the player reaches the final square. So I added a variable whose whole job, game in play, is to keep track of whether the game is currently in play or not. When you see other people's code like this, you begin to use their techniques in the code that you haven't yet invented. So whoever created Fortnite, whoever created Minecraft, the great Gabe, who was in charge of one of those gaming companies, he has the last name, but they call him Gabe. All those developers, they grew up seeing examples of code from their teachers in maybe books or online resources. And then they read the comments and they added features to the current version of whatever they're in charge of. So game and play, handy thing to have. Okay, the rest of this is all just obvious stuff from previous workshops. Getting my pens colored, coded, it's pen up, go to certain XY locations on the screen. And now we get to the functions. Oh, look, I'm folding up my clothing so it's nicely folded. I love doing this at this website. It lets you do this. Code folding. See, it's like a pair of pants that's folded up. But look, when I do this, I click that little triangle, it's unfolded. Folded, unfolded, folded. Some people, they like to go around with everything folded because they don't want to see the details. They don't want to see that the pair of pants, like, I don't know, has a logo in the back pocket, but they folded it up so that they could unfold it and see that logo, but they don't have to. when you work on something abstractly, you don't care about the details. You only care about the names of the functions, DEF, defined functions, and that's all you need to know. The car has a reverse gear and a forward gear, so I can drive that rental car. I don't need to go to like Ford driving school. Maybe I drive Chevys, but as long as I know it has forward and reverse, I know how to drive that car safely on the highway with other people. But if I'm the engineer at the company Ford, and I need to make it a better car or a faster car or more fuel efficient, then I would have need to come into the body of a function and tweak the code there. So knowing how to deal with something abstractly is one of the computer science standards. And this is probably true in life in general about a lot of things. Abstract versus detailed, also called concrete when it's detailed. Okay, so draw square, we've already learned, we wrote this function in a previous workshop, that draw square, it draws one square at a time. But draw board, that function, calls draw square 12 times. Because right now I have 12 squares on the board. So these are call statements that are having draw board make use of draw square. So it's like a tag team kind of thing. It's not the other way around. Draw square does not call draw board. Nowhere is draw board typed or referenced in the body of draw square. So always use functions in the idea of reusing them and having them help each other if you can. You will go further in coding life in computer science if you organize your code this way. There's no law, of course, that says you have to use functions, but it's a good idea. It's like many of the standards that you need to apply relates to this idea. And passing parameters, like right here, where I have left 1, comma, bottom 1. If left 1 is the number 0, and bottom 1, for argument's sake, is like the number 10, then 0 and 10 plug in for x, y. But down here, left 6 and bottom 6 are different numbers. And they plug in for x, y also. So x, y is like they are reusable parameter names. Math teachers call them variables, x and y, like the f of x. But you don't know what number is going to be plugged in there until they give you a word problem or just a busy worksheet problem. We have this thing called Study Island, and it's just like they throw in different numbers. Okay, shh, we're on video here. The Study Island people might be watching this video. And by the way, half of them are coders, although off the record, I don't know if they're the best coders, because I think I've seen glitches, but maybe they're just doing their calculator upside down or something. Maybe they should debug their code better. Okay, so there are jobs out there for people, like people in this workshop right now. Draw square. It makes use of those two parameters, and draw board makes use of draw square, which makes use of the parameters, and it's all just a bunch of dominoes. And last of all, the function move player. It's where all the action is. Well, a lot of the action. We studied this in previous classes. Maybe I'll look into it later, but right now I'm folding that up and just looking at it abstractly. Now I ask the question in the audience right now, up to line number 221, we'll say, up to here, is anything really of worth happening if I stop the code and just type in a premature exit? If I type the exit command prematurely and run this, does anything happen? No. In fact, I hit the space bar and nothing moves, and we're not getting a board drawn. So really, everything here is the setup, except for the black background, pretty much. It's just the setup. But it's good to set things up strategically so that when the game starts in what I call the main program area, now we're ready and organized for reusability and efficiency and all that. So I take out my exit that was just there temporarily, and now really, this program is only 4 lines of code. Not counting the green hashtags, it's just 4 sticking lines of code. And draw board, that's a call statement that calls draw board, which we've already talked about, calls draw square. So this is like the first domino that when this executes, we stop with a pause button, kind of like down here, and the computer comes up here and dives into this. It then does line 126, but that pauses and calls draw square, which is line 113. When we're finished here with the indented code that's folded up here with line 120, when we're finished with that, we go back to line 127 and draw the next square. When we're done with draw square that second time around, the computer goes to line 128. And the computer's really good at this. It does it really fast in microseconds, as long as the coder indents everything correctly in Python and spells everything correctly, and strategically designed it correctly by paying attention to videos like this and then practicing and making themselves perfect or close to perfect. Don't forget about loops. We learned about those in a previous workshop, for loops. That's like one of the standards. You should know how to use for loops. Okay, back to the main program area. After it draws the board, I'm going to exit right there prematurely. Exit, empty parentheses, run this, and the whole program, except for spacebar interaction, works. So right now I hit the spacebar and nothing's working, but at least it looks good. But right now I have not allowed the computer to execute these 3 lines of code. So I take out my exit there. That was just a temporary thing. And now, if you study Python, which I'm helping you right now, screen.onKey is essentially telling the computer that anytime somebody hits the space bar, that the move player function from up above should be called and therefore executed. And by the way, in case people don't like the space bar, they can press the lowercase letter r, which in my mind means roll dice. But you can pretty much train any of the keys on the keyboard to respond and do different functions. Like we could have a function called reset that resets the game, but that would be an upgrade idea for later. We could have a key that's like an Easter egg, and that when somebody hits the letter, say M, it sends me, a bunch of Bitcoins. That would be appreciated, like PayPal money. But who knows? Maybe I did build that into the code somewhere. So be careful with what letters you press. You better read my code, because I might be getting Bitcoins from your bank account somehow through some kind of token and exploring your hard drive for where you have your Bitcoin encrypted tokens. Oh, that's a thought. Anyway, it makes me a little paranoid now when I use apps on my home phone. Geez, you mean that flashlight actually has things happening behind the scenes that I don't know what it's doing? Yeah, they do that when you have malware. Okay, back to this program. Screen.listen. If you don't put screen.listen, you can hit the space bar all you want, and it's not listening. See, it's not moving because it's not listening. So screen.listen basically activates the screen.on keys that were right above it. So that's just a little Python stuff that's like extra that you need for this to be interactive. The program now runs, and we've done a walkthrough of a lot of parts of this program, but except for the main area of the function move player. Move player is where most of the action is. So I'm going to do a quick walkthrough of that. We have 2 variables that will be updated as the game plays, player position and game and play. They were set equal to things up here. Player position is 1 and game and play is true. But to have the right to update them, you have to type global. You just have to. That's the way Python is. Then because of indentation, everything else is part of this folded function called move player. And this if statement, we've already addressed that a little bit. That ejects you if game and play is currently false. The return ejects you. So you don't get to see the rest of the code below this. So it's just a kill switch, basically. Let me run the program and show you that real quickly. If I hit the spacebar a bunch of times, I eventually win this short board game. And there I won. And there's a glitch because it reset. And I thought I had changed that. Let me scroll down and make sure that this one spot. Yeah, there's a small glitch right here. Move backward. No, I think I just hit the spacebar too fast. I overwhelmed the listening. So at any rate, this works at least 90% of the time. And now let's look at this code here. We went over this in a previous workshop, but I want to like rehash it a little bit in this video. That's the rolling of the dice. By having a variable called random num and storing rand int 1, 3, some number between 1 and 3, like 1, a 2, or a 3 is rolled. I could change that to 6, 1 to 6, but my board is so short, people would win like instantly. So I cut it down to like 1 to 3. And you would not want negative numbers there. That would be like mean. People would go backwards. And this plus equals, that just adds the random number here into my running total, which is really the variable player position. Yeah, I could have probably combined those 2 lines of code into 1 line of code, but I think it's very readable this way, especially with this hashtag comment right above it. So that's the rolling of the dice. And then I clear the last dice roll, and I tell the human what was rolled down here in this area here. I don't have to do that. I could have it be a mystery and have people just have to count how many squares they moved. But this little update status bar area, you know, like knowing your damage in Fortnite, it's just nice to know, like, you know, if you can like get away with something or not and take a risk. So you could put other things in that dice pen area. You could add damage or health or a timer to this project as an upgrade. Consult with me later, or just look at more of my online examples somewhere at minic.com. So the dice pen with nice little white space around it, so it separates it from like the other main logical sections of this function. And now moving on to the next little mini section. Oh, it's not so mini. It's one giant if, else 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 if. It's to infinity and beyond. You always start, this is review, with an if. Then your parents or your boss or your teacher or somebody in your life says, oh, else if this, then do this. Then they like throw another else if this is true, then do this. It's only one of them that happens. It's the way it works. It's like mutually exclusive. The first one that happens is the one that happens. The rest of them are skipped and ignored. But it starts with if, and then there's optional else ifs that tack on. You don't need to put blank lines in here, but I just do for like good style. And really, it's pretty logical. If player position is currently 1, that means I want to draw the player on square 1. If player's position is currently 2, if the variable player position is at a 2, then draw the player at square 2. Now I could totally mess with people and change the logic of this program, but I wouldn't do that. And does this workshop end at 6:30 or 6:45? 7:30? At 30 minutes? Oh, okay. So this is basically an end here to where we are. I have 2 special squares in there where I have a pause and I fill the backgrounds. We've already talked about win detection, I think, last week, where I have a greater than or equal to symbol here instead of these double equal symbols. And then I display win. So I'm going to run this one last time to make sure it's working. I hit space bar or the letter R to roll the dice. It seems to be working. There's a pause there. It moves back 2 squares when I hit square 8. It jaywalks illegally there, but oh well. It's game in play is currently false. Spacebar is disabled, and the game was over there. So that's a wrap on this video and this workshop. So let me know if you have any questions about those standards. Here they are in this tab window that before was hidden. The standards that I was referring to that you should just know for future understanding are on this website. And a lot of them were right here, like use loops and if statements. Break a problem down into many parts of different functions. It's called decomposition, decomposing. Creating reusable functions or procedures with past parameters like X and Y. Getting feedback from other people so that you can make the program better with like better instructions. using existing code like imports or other people's DEF functions when possible, systematically testing your program little by little with different possible inputs, distributing tasks to other people so that you can break things down and work collaboratively so that different people can write functions and then they can all be merged together into the final project. This guy Dylan knows to always add hashtag comments and document your code to explain it to other people. And this guy named Sawyer knows that in the real world, even though it wasn't really stressed in this workshop, that there's always trade-offs. Sometimes we need exercise, especially on a nice day like this. And coding all night long, even if you could create YouTube like Chad Hurley did, who went to Twin Valley High School, isn't necessarily a good thing. That you need a balance, but often you can save a lot of people and make money at the same time by writing code efficiently and then still having it left over time. Okay, so that's a wrap, and that's a place where you can see the standards. Okay, hope this helped, and Minic.com if you have any other questions, Minic.com with one N, Minic.com. And a lot of extra learning can be found by clicking the word Python here. And there are a lot more videos and such and demo programs here on this website. Have a great coding life.